Start. So today I am going to teach you about graphical representation of motion. So in the earlier classes I have told you about what is speed, what is velocity and what is acceleration. And in this class we are going to study how to represent these acceleration, velocity, distance and time in a form of graph. So let us proceed. So it is written there that graph provide a convenient method to represent basic information about variety of event. For example, in the telecast of one day cricket match, as we have seen cricket match, we see that we see a graph by which it is easy to understand that which team is in good position and which team is going to lose the match. So it is saying that graphical representation gives us a basic information about the variety of events such as cricket match. Vertical bar graph show run rate in the team, as you have seen in the TV. You have also studied in mathematics. You have also studied in mathematics about line graph, bar graph, and linear equations of two variables. Now to describe the motion of object we can use line graph. In this case, line graph show dependence on the physical variety such as distance, velocity on other quantities such as time. Now I will teach you about distance, time graph. So what basically distance time graph means? Distance time graph means the rate of change of distance in time. Okay, for example, if we calculate something, for example the speed of a car. So for example, these are the values for distance and time. For example, we say that for 1 kilometer so we say that in 1 minute the car traveled 1 kilometer, and in the second minute the car traveled again 5 kilometer, and in a third minute the car traveled 6 kilometers. So how we represent this in a form of graph? So we will take a graph, and we know that this is x axis and this is y axis and this is origin 0. So we can take time in x axis or in y axis, it's your choice, and I am taking time in x axis and distance in y axis. So this is 1 minute, 2 minute, 3 minute, and this is 1 kilometer, 2 kilometer, 3 kilometer, 4 kilometer, 5, and so on. So what is given here, that at 1 minute the car covered 1 kilometer. So at 1 minute the car covered 1 kilometer. Okay, so this is the point in the graph. And in the second minute the car covered 5 kilometer. So here is 5, and so on. This is 6, and 3 minutes the car covered 6 kilometer. So when we join this, we get an line. This line is not straight because the motion is not a uniform motion. The motion is a non-uniform motion, and if it is a uniform motion we get a straight line. So thank you.